Hi everybody, and welcome to this talk called a do-it-yourself guide to building your own rendering engine. Before we start, let me introduce myself. I am Francesco Strazzullo, also known as Straz. This is my code name. It's more than my code name. I think that everybody calls me like that apart from my mother and my girlfriend. I think also my sister called me like that. And this is my Twitter handle. My direct messages are open, so if you want to talk about my talk or whatever you want, if you have any question, you can just write me on Twitter. I work at Flowing. Flowing is a software company based in Italy, but we are a remote-first company, so we are scattered around every part of Italy, from north to south. And I think that our main characteristic is to co-create our software with the client in a very inclusive way. And I think this is the only way that we can build useful software together with our client. So let's start the talk. I usually start my talks with a section that I call Start With Why, quoting the famous book from Simon Sinek and his famous TED Talk. The point is I try to explain why this topic is important for me. It's important for me to be on this stage talking about this topic. So the point is, why should you learn to build your own rendering engine? Let me tell you a story. And I promise that it will be short, okay? I don't want to tell the story of my life. But I think that this story could be useful to understand how came up with learning to build rendering engines from scratch and why it's important. Some years ago, I was not working for my current company. It was some time ago, but I had, with my team, to create a front-end application above an existing old Java framework, something like JSP, something like that. The point was that the client was, if I remember correctly, a bank or an insurance company, okay? So we are talking about that kind of environment. And on top of that, we had to create some kind of interactive user interface full of Ajax, full of cool stuff about that. I know it doesn't sound interesting as a project, but we said, okay, why not? Let's try. First problem, we couldn't add new dependencies in the project. We couldn't add any link from any CDN for their policy, and to add the dependency in the project, in the package JSON, we had to write to the CTO, and the CTO should ask the CEO, and I don't know who else had to put a signature on that stuff to add the new dependencies. So we said, okay, let's stick with what we have. I know this is not going well, okay? This is going worse and worse, but it's not finished yet. The only available libraries were jQuery and underscore. We didn't have any other stuff, because this was the only dependencies that were approved by the client. Because the point was that they did everything from the server side, okay? They generate HTML from the Java, and they said, okay, you can just use some JavaScript to manipulate the DOM. Okay, you may understand that it was a very, very explosive situation, okay? But we tried in any case. The point that was we delivered the project in time, and honestly, I don't know how. I really remember that times I was confused, but the point was, what I remember is that our team was unhappy. And why our team was unhappy of a delivery project? We should be happy when we deliver something. We were very, very sad. Sad like this poor kitty down here. We were sad because we delivered a lot of spaghetti code. And when I don't mean, you know, in Italy, we love spaghetti, okay? So when we say spaghetti code, it's hard to imagine a bad thing. But as you can see, I chose deliberately a very bad plate of spaghetti in this image. Okay, it's not a carbonara. Okay, it's some kind of microwave spaghetti bolognese. Okay, I feel something here. Okay, so our code was a mess. Okay, that's the point. Our code was really, really a mess. The point is that it was a mess because actually we panicked. Looking at that in retrospective, we were not ready to do that. It was like, you know, when you're learning to swim and someone just throw you in the lake. That was the point. We panicked, so we started writing code without thinking about architecture, without thinking about the consequences. And we panicked because one of the first rules that every JavaScript developer knows when they work with tools in general is that never manipulate the DOM. If you think about it, every framework out there tells you that you shouldn't manipulate the DOM. Or if you do that, you should do in very hidden places in the code because you don't have to do that too much. For example, if you take React, it's true that it gives you an API to get the actual DOM element, but you know it's not so used. It feels strange if you do that in a React application. The same thing in Angular or in Vue. The point is that manipulating DOM is hard. I know that I'm not saying you anything new. Everybody knows that manipulating DOM is hard. But my point is that the fact that manipulating DOM is hard should not be an alibi. If we want to be professionals, if we want to be senior developer, we should be able to do that. What I mean is that we should be able to own rendering code. Rendering is a core part of every front-end application. One of the main features of front-end application is to show data. So what I mean is that it's too important to not know how to do that. In fact, after that I learned how to do that in project, once in a while I do this stuff in production. What I mean with own? With own, I mean that you should be able to understand rendering code from other people or framework. You should be able to write rendering code. I'm not saying that you should be able to write all the React framework, but you should be able to start writing something in that direction. And most importantly, you should be able to adapt the architecture of the front-end framework, of the rendering engines, to your actual problem. So let's try to do it. Let's try to do something together. Before we start, I would like to list some principles that I follow every time that I write something from scratch. It could be a rendering engine, it could be a state management library or something like that. It could be also any kind of business logic code that you want to be separated from the rest of your frameworks and tools. The first thing, it could may seem stupid, but it's choose a simple architecture. I want to focus on two words here. The first one is choose. It may seem strange, but it's not so easy to choose an architecture. Usually, we adapt to an existing architecture. We choose a framework. And with the framework, we get all the decisional architecture that the team of the framework made for us. If you choose to work with Angular, you are deciding to use RxJS. So you are deciding to design your application in the RxJS way, in the reactive way, or to be more precise, in the reactive implementation of the creators of RxJS. If you're using React, you are using the declarative pattern, because in React, you never manipulate the DOM, but you say, how do you want your DOM to be? And then React with a virtual DOM does the stuff under the hood. But you are not choosing it. You are choosing React. So it's not easy to say, OK, what is the best architecture for my problem if you have to write something from scratch? It's something that should be I started to do. It's not easy, but it's very interesting. The second one is simple. What I mean with simple architecture? I mean that you should write down an idea, a simple idea like this one. If I have to explain all the code that you will see in a single slide, is this one. All the DOM elements that I will produce with my code will be a pure function, the result of a pure function of the state. That's the core idea. Of course, this is not an architecture. So don't imagine that I will give you some kind of UML of some kind of graph of code, OK? And of course, this slide is not enough to explain how to build something. So the point is that I follow another principle after that I chose a simple architecture. And this is the Nyani, or I really don't know how to pronounce that, but it's an acronym for you are going to need it. What does it mean you are going to need it? Every developer has the temptation to predict the future. When you build something, and when you and me, when we build something, we usually say, OK, I think that this piece of code can be useful in the future. And then you put that in an abstract class, in a util or something like that. The point is that you can't really predict the future. And you usually fail when you predict the future. So the point is that you should adapt your architecture to the feature that you are developing, to the context around you in real time. It's not easy, of course, but this is the reason because you have to choose a simple architecture. Because a simple architecture is easy to adapt, to evolve to stuff. And what I tried on my skin is that if you try to write something from scratch, and I'm not saying something complicated, but for example, if you try to write a simple Redux clone from yourself, and I can assure you that it's not so complicated as you may imagine. It's around 80 lines of code for a first draft, of course. But if you build it yourself, it's easier to adapt to what changes. If, for example, you start with a Redux clone, okay? So it's an event-based architecture, okay? It's some kind of event bus. If you want to transform that in a reactive application, it's not so difficult if you own the code. The other principle is this one. It's a quote from Donald Knuth. Premature optimization is the root of all evil. Probably you saw this quote sometimes in other talks. It may seem easy to say, but in front end, we have a problem. Performance is UX. So you have to be performant. And I know that this message could be confusing, okay? I know that you say, okay, but it's important, so I need to care about that or not. The point is that you should not decide your architecture around performances. What I mean is that you should draw your code as you feel it's good for your domain, for your business logic. And then measure, measure, measure. Every time. Measure every time that you make a commit, measure your performances. This simple tool is called stats.js. You can inject that in every website, on every browser, and they will print on the screen frame per second, latency, memory occupied, and also custom data if you want to measure something else. And not only that, in the project, I also automated a test of performances with Puppeteer. You can use the window performances API of Chrome and automate a test that say this page should render in less than half a second, for example. So if your code is not performant enough, it will break. And then you can adapt your code to be performant. What I mean is that you not should be afraid of performances, but you should measure that to act accordingly without trying to change your architecture. This is the last principle, and this is eat the frog. What I mean is that usually when you have a very big project ahead of you, you have this big project, you have a lot of functional requirement, and if you are lucky, you can split this functional requirement in user stories. Usually you put this user story in a backlog, and you start the first sprint. Usually developers tend to choose as a first user story, as a user I want to log in. The point is that if you are using a framework, for example, React, you know that React can actually render complicated stuff because you trust React. The point is that you can't trust your code. You shouldn't trust your code. You should test your code against real problems. So the point is that start from the most difficult task. If you have, for example, a login page, and then after that you have a very, very huge list with a lot of elements, start doing that and mock the login. It's not important for a rendering engine. If you think that performances and rendering is important, attack that problem first. It's time for a demo. All the code that you see, it's visible on GitHub, and I will share with the conference the slides and the code, so you can take a look at that later. But let's take a look at the code together. Our purpose is to build a clone of ToDo MVC. With random data, oh, you don't see anything. OK, but you know ToDo MVC probably. And what we have to do is to print a ToDo MVC list that change randomly, because we are simulating user inputs in this demo. OK? So let's start with some code. We will do 5 iterations of this code. We will see the same code 5 times, and every time we're going to add something. Okay? In this first example, we just print static data. Okay? So this is our index.html. So I create the basis structure. You can see this is the markup of the ToDo MVC app in the body, just like that. Then I create a GetToDo's model. This is just a simple function that uses faker.js. That is a very lifesaver tool if you are a trainer or a public speaker, because it creates random data for you without getting that on the internet. So I create just a random number of to-do with a random number of words and so on. Just a random list of to-dos. Then I have my index.js that you can see as my controller. Is the part of the application that binds together the state and the view and the browser. So what I do is I create the state. So I create the list of to-dos and the filter. You can filter for all to-dos, for the completed or the unfinished one. Then I take from the DOM the to-do app. So I take this piece of DOM. And then in the RequestAnimationFrame, RequestAnimationFrame is a callback that the browser gives to you to manipulate DOM just before the next rendering cycle. So it's the best part to manipulate actual DOM. If you have to manipulate DOM, every time that you do that, just put that in a RequestAnimationFrame instead of in setTimeout0, for example. I know that you do that. I know. So this is the way that you should do that. And if you work with a very, very old browser, but I hope not, you can just polyfill that with a setTimeout in that case. So what I do in the RequestAnimationFrame, I create a new main DOM element. As you can see, this element is a pure function of the original element and the state. Okay? So I use the original element as a stamp. I clone that. I don't manipulate that. This one will never be manipulated. And then I replace it entirely. This is our first version of a rendering engine. I create a DOM element on the HTML, an actual element. I create a clone of that element based on the state on the variables, and then I replace it. Okay. Let's take a look at our view function. Our view function, so you can see it's a function of the target element and the state, as I said. I extract the data from the state. I clone the original element. The true word means deep. I clone it deeply with all the children. Then I chose 3 elements on the DOM, the list, the count, and the filters. These things will become components in the next release. Okay? But for now, just focus on this code. Then what I do? I said that list.innerHTML is equal to a map of the to-dos in a something, GetToDo element. So I transform an array of to-dos in an array of HTML string, and then I put them together, and I put that in inner HTML. You may say that this is very, very unperformant, but remember that we are working with a virtual node. Here, I clone the node because I want to create another element. So if I manipulate them, I can manipulate it in any way I want. Also, not so performant, because it's not related to the browser. The browser will not listen to this manipulation. So if you measure performances, you can start simple, like that. Then I take the counter, and I say that I print the to-do count, how many items are left to check on the list. Then I take all the filters, and I say that if the text content of the link on the filter tab is equal to the current filter, I add the selected class, or I remove that. And that's it. These are our first edition of our to-do MVC application. As you saw, I respected my contract that I show you in the slide. My view is a pure function of the state, and in this case, also of a target element. But this code is quite ugly. Because if you see, we have this GetToDo element here. We have the to-do count here. You see here, I just take the to-dos and I print the string. Here I print something with string. It's quite bad. And it's bad not because we're using strings. We know that using strings will not scale on bigger projects, but this thing is quite easy to remove. The problem here is that we are breaking one of the most important rules in code design, separation of concept. This function does everything. Okay? So the next iteration is to actually split this view function in 3 smaller functions. What I do is I create the to-dos view, the counter view, and the filters view. Like I said before, these will become components. The first step is, okay, I have to create some kind of component system. I don't know how. I don't care how now. As the first thing, I will just remove the code away from this application, for this code. And then what I do? It's the same thing as before, because I create an element. I choose the original element on the virtual node, and then I replace it with a result of the new view elements list. You have to notice something. All these functions, 1, 2, 3, and 4, have the same signature. This is very, very important, and you will understand why in a moment. Let's take a look at, for example, the simplest one is the counter. Is the element that prints how many items left you have in your list. Target element and the to-dos, the state, we extract the to-dos. And we just clone the node, print the string, and then return the new element. It's not important the code right now, okay? I choose a stupid application because I want you to concentrate on this stuff, the signature. The important thing, one important thing of this architecture is that they are pure functions, like I said before. And what we do with pure functions? We test them. This is some tests, unit tests that I wrote with Jest. And you know that Jest is contains also JS DOM, so you can test fake DOM elements in Node, so quite fast. And you can say that I just test a counter view with a target element that is just a div in this case. I don't care about the original element, it's just an empty div. And I say that with these to-dos, when one is completed and two are not completed, the content should be 2 items left. Not only I created a small rendering engine, I created a testable rendering engine. It's not so easy that. It's not so, the first time that I did it, I created some rendering engine, okay? Because I said, after a while, you learn how to manipulate DOM. The point is that if you create messy code, you don't know how to inject test. And then I also do the other test that when there is just one, I say 1 item left and not 2 items left. 2 items left. I do this test because there was a bug. I forgot to remove the final S for singular for. But I can test also the filters. I can test also the to-dos. I can test everything because everything is a pure function. Okay, this code is better because we split the code, and now every piece of code is making one thing. So we have separation of concern. But I don't really like one thing in particular. Take a look here. I need to manually connect and invoke the selector with the function. When you create a component, you create some kind of universal tag that you can use in your application. If you work with Angular, you can use a component and then use that tag in any part of your application. You don't have to manually connect the pieces. It's the framework that does this stuff for you. And I want this stuff also in my code. So let's see how can we create a simple rendering engine with a custom element registry. Okay, so let's start. We have 3 components. We have the to-do list, we have the filters, and we have the counter. Take a look here. Data component, to-dos. This is a custom attribute that I added to the to-do list element. Notice that this was the selector that you saw before, and now in the HTML, I put the data component to-dos. I did the same thing on the filters, and also the same thing on the counter. What I did here is to mark my components. My components function should automatically attack that pieces of DOM. I don't have to do that manually. This is my public API. Okay? Let's see. This is how Angular works, okay, under the hood. This is not so different from ng4 or NRG model from an architectural point of view, okay? So let's take a look on how I have to change the code. I don't have anymore the app component, the main view function. I just have my controller. I have the 3 functions. They are still the same. The code is exactly the same as before. Then I import a component registry. That is another piece of software that I created in this case. And then I say that I add to the registry a to-dos element with the to-dos view function. Then I do the same thing with the counter and the filters. At the end, in the usual RequestAnimationFrame, I just take the main element, and then I say render root main state. This thing, it's very similar to another instruction that most of you use. It's render DOM.render. The point is that our registry should boot in some way. We should say, okay, start doing your stuff. It may seem strange, but now we'll see the code of the registry itself. The first thing to notice is that our registry is actually a simple JavaScript object, where the key is the name of the component and the value it's not our component, but it's something else. As you can see, the add just say that registry name, so in the first case was to do, so registry to do's, it's equal to a wrapper of my component. This wrapper is an high-order function, an high-order component, if you want to say it like that. Take a look. Our render wrapper is a function that takes a component as argument and return what? A function with target element and state. What I said before, keep a look at the signature. The signature with target element and state is what, in our context, is a component. So I take a component and I return it a new one. This is a basic concept behind high-order component in React, for example. So I invoke the original component, and then I look for every element that contains the data component attribute. Okay, so in this case, I have the 3 components. And then for each of them, I extract the component name, to-dos, filter, and counter, and I replace it, I invoke it. What I created here is some kind of recursive function with components, because the only way to add a component is through add method. So every component, it's not an original one, but a wrapped one. So every component will call itself and all the children, but the children will be wrapped again, so they will invoke the same function again. But how can I start this process? This is why I need the render root. Remember that here I have the complete DOM element, the to-do app. Here I have the state. Then I create the most simple component out there, called clone component, that I take an element and I return the exact clone. I needed this to put it in a function, and this component will just be invoked with a render wrapper. So I wrap my component, my original DOM element with a wrapper, and then I invoke it. It's not so easy to understand. So let's do that, looking at the step by step. Okay, so it's here. Here, I just lost the file. Okay. Let's start with Yacht. Okay, we have our 3 functional components. Okay, we should understand now what they did, what they do. Then we add these functions to the registry, and these functions are actually wrapped a component that then will invoke all the children that they found inside themselves. Then I say, okay, take the to-do app, invoke the render root, but the render root is another wrapped component. So what happens is that this thing is cloned, then is traversed until they find to-dos, counter, and filters. Then for every one of its elements, they replace it with the connected element, connected component by this name. That's it. You just saw a first implementation of a rendering engine with a custom element registry. But how can we manipulate? We just printed static data until now. What we have to print dynamic data. Like I said before, I don't want to cover in this talk because it could be too much stuff. Also the user input. So to simulate that, I just create a new to-do array, a random array, and then I render it again. What's the problem of this code? Every time I replace the entire DOM with another DOM element. Every time. This is not performant. So the problem, it's not in the code itself. The point is that if you are manipulating something not bigger, it's not a problem. We have powerful PC and mobile phone. You are able to do that if you are not doing something very big. But do that with a very, very large list, it will become a problem. You can see that with stat.js. So how can we fix this? The suggestion here, and I suggest to see the next talk to go deeper, but the point is that learn from the bigger virtual DOM. In this last example, what I do is that every time that I render, I create an apply diff algorithm. This is a very, very stupid virtual DOM, okay? Don't believe that it's so complicated. I will show you in a moment. But the point is that this stuff only apply the real difference with the actual DOM and the virtual DOM that you created, exactly like React. Like you saw, when I had a performance problem, I tried to not change my architecture. I didn't change the code of my components. So let's take a quick look at the apply diff. It's very, very, it's almost too stupid to be shown. It's not a real virtual DOM, but it do its stuff. The performance has become quite better, I have to say. This apply diff takes 3 parameters. The parent node, that at the start is the body, the real node, so our actual component, or the component that I print the last time, and then the virtual node. And then I say that if there is a real node, but there isn't a virtual node, just remove the real node. If there isn't a real node, but there is a virtual node, add the virtual DOM to the parent. If node is changed, it is a private function, but it just say that, for example, there is another attribute, there is a different attribute, or there is a different text content. Okay, it's not complicated. I just say if something is changed, replace it. Replace the real node with a new one. And then, for every children, apply the same stuff, apply diff. That's it. We have created a virtual DOM algorithm in 68 with white spaces row. This is what I meant when I said keep your design simple. I created a very, very stupid virtual DOM, and I said it's good enough. Surprisingly, for my use cases that work for standard web application, it works enough. It's fast enough to be in production. Okay, so now that we saw the code, what's next? What we have to do now to continue investigating this stuff? The first thing is to add event handlers. Okay, of course, I don't have the time to do that, but what you have to do is to learn, for example, the difference between bubbling a capture phase. It may seem strange at first. Then you have to know, for performances, how to create an event delegation system. The event delegation system aims to not create 1,000 of event listener, but just one event listener on the body that capture everything and then try to understand what you have to do. Event delegation is another of the core mechanism of React, for example. The other one is web component. Web component is a standard way, a native way of the browsers. With that, you can create custom tag components, just like React or Angular, but without any kind of framework. So you can release this stuff without the runtime. It's just simple JavaScript code. So you can attach it in any website that you want. They are already shipped in Firefox, Safari, and Chrome. They are releasing in Edge in this year, but they are throwing away Edge, so there is not a problem. And they are polyfillable on Internet Explorer 11, so you can use this stuff in production. What I learned, I created some rendering engine for application in production, and I understood that manipulating DOM is not so hard. I'm not saying because I think that I'm the best developer out there. I'm saying that because we should not be scared of that. It's not true that we should never manipulate the DOM. We should be able to do that, and we should decide when to do that. You don't have to believe that I started writing everything from scratch every time. I start writing something from scratch in existing application. So in existing frameworks, in existing application with Backbone, jQuery, Angular JS, Angular React, whatever you want. It's easy to inject this kind of code in a real application, in existing application. So what I mean is that this is not a black or white solution. You don't have to say, I want to do everything from scratch every time. I don't want to use a framework anymore. Or you don't have to say either, I can't live without frameworks. The point is that you have to be able to choose when it's useful to do something from scratch. For example, I helped a team with a consultancy about a performance issue with React. They had a PVA about was a local news journal. Okay, so the main point for the application was the infinite scroll of the news. It was very, very slow, 15 frames per second. The point was that they were not so able with React. And I said to them, the scrolling, the list is your core element in all the DOM. I don't care if you write your login with React. I don't care if you write your advanced setting with React. What I care is that you own the code of the list, because your business runs on that list. So we created a list element in React, but inside the element, we created a rendering engine, very, very performant for that list. In a day, we are going to 50 to 45. It's not good, but we started with the old code, so it was a bad situation. But right now, we are on 60 frames per second, and we are testing it with Puppeteer. Now the point is that you decide if it's a good solution. How to decide if you should choose React or a frameworkless approach? Sorry, it's not for today, because it's another very, very complicated stuff, because we are talking about decision making. It's not about code anymore. Or it's not just about code anymore. But if you're interested in this stuff, tomorrow I will be in Bolzano to talk about a tool that will be developed in Flowing called Framework Compass Chart, that we use to help team to decide then what framework should they use for the next project, or if they have to work without any framework. You can find something on Medium that I wrote some time ago about Framework Compass Chart. This is a very, very small version of my talk of tomorrow. So if you're interested, you can take a look at that. Or you can talk with me at lunch. One last thing. As always, I'm very proud to be here on this stage. But this year, I'm very also happy to announce something. And I'm very happy to do that on this stage, because this was my first conference as an attendee. And here it is where I decided to become a speaker, to start public speaking. And today I want to announce that I'm writing a book about frameworkless development that will be published with a press by the end of the year. And for me, it's a very, very achievement to say that out loud. It's almost a year that I'm working secretly on this stuff. So I'm very, very happy to show you the cover. And all the code that you saw actually is come from one of the examples in the book. There is a chapter about rendering. And this talk, this book, the talk of tomorrow, they are all part of something bigger in reality. Something that I announced last year on this same stage, or perhaps the other room, I don't remember. That is the frameworkless movement. I and a bunch of crazy friends decided that we want to bring all the people that are interested in working with our frameworks together. We are creating talks, books, videos, events. We did in Treviso, where I live, a frameworkless hack night, where a bunch of 20 front-end developers tried to create Twitter from scratch without nothing, and then they exchanged their ideas in front of a beer and a pizza. And if you're interested, I suggest you to go on the frameworklessmovement.org, we have some information. We have a GitHub repository with the manifesto of this movement, with the principle that we believe in. But it's quite a strange manifesto. You cannot sign it. You cannot sign it. You can just put star on the GitHub repo, but you can change it. You can open a pull request if you feel that something is off. You can just write an issue. The point is that we don't want to tell the truth. We want to share with each other. So if you're interested in this stuff, please be involved. Thank you very much. It's been a pleasure to be here today.